Hey guys, welcome to the shop. I'm Tom Coutron, and standing next to me is a 1946 Induma horizontal mill. It's a model UR-2. It's 5 horsepower, got a category 40 taper spindle. It's got rack traverse in every axis as well as power feed. Right now it's wired up and running after sitting for probably about 10 years without use. Machine seems to be in fairly decent condition. All the dovetails are hand scraped and don't show signs of too much wear for its age. This machine was made in Milano, Italy, and I'm fairly certain it was made right in 1946. It's got an on-off throw-out clutch up on the top for the engagement instead of an electrical switch. The machine seems to be built really well for its age. The machine is very heavy. It's just over 2 tons. When we had it unloaded, the rigger was using a Hister forklift and it handled it fairly well. But it's definitely a heavy machine, and getting it into the shop on a pallet jack was quite the chore. As of right now, I've only taken a couple cuts with it, so I'm not super familiar with it. Most of my experiences with Bridgeports and similar vertical mills over the years, but I knew it was time to get a horizontal mill, so I figured I'd put some money into it and get one. And I think I got a really good deal on this one. So, a little bit about me. I am a mechanical engineering student at Worcester Polytechnic Institute in Worcester, Massachusetts. I'm from Huntington, New York, on Long Island, and I grew up there my whole life, and I'm in my 3rd year of college here now, and I just love machining, and I teach classes here in machining for other students, and I help make parts for just about anyone who comes into the shop. So this is actually in the Worcester Polytechnic shop. This is my machine, but the school is allowing me to use it in here for the next several years until I graduate. And then from then on, it'll come to my home shop, where I also have a South Bend lathe and a Sheldon Vernon vertical milling machine and jig boring machine. So otherwise on this machine, it's similar to a Cincinnati style vertical, horizontal 2AH mill. It's similar in that everything is based off of dovetails, whereas similar Kearney and Trekkers would have the tube type horizontal overarm support. This one is dovetailed, and it's got probably a 400-pound ram up on the top. When I first got it, it was fairly stuck, but once breaking the quick rust seal, we were able to get it sliding, and it slides real smooth now. Otherwise, the machine is 40 taper, but it's NMTB 40. It's got the extended tang on it, and from what we use at school with a lot of the Haas CNC equipment, they're category 40 taper. And I've adapted this machine to take both category 40 taper as well as NMTB. And what I did was I took one of the drive dogs off the machine, and I surface ground it down roughly 75 thousandths to get the category 40 taper tooling to fit. The drawbar is long enough to hold the Cat 40 taper, as well as short enough to hold the NTMB 40 taper, because they have the extended threaded section above the taper. So as it sits right now, the mill is not leveled. I just have it on wood skids because it's only been in the shop for roughly a week. It sat in the loading dock for a little over a month, and we had to wait for a rigger to unload it for school safety purposes. And as of right now, I've changed the oil in the machine, all of the various gearboxes, roller chain gearboxes, as well as spline shafts that run on the power feed. I've drained all of the oil in the knee, as well as the spindle housing, and I replaced that all with all of that oil with a spindle oil, a heavy-duty spindle oil, a DTE 110, I believe, and that is the closest thing I can find equivalent to what this machine takes and took back in the 40s. They recommended Gargoyle Aetna engine oil, mineral oil, and that stuff obviously I cannot find today, so the closest thing I could find was that spindle oil. And so we have that on campus, and roughly 1.5 gallons later, 2 gallons, I filled everything back up in the machine and got oil flowing back into it. From there, what I did was on all of the column surfaces and way surfaces, I took a 2000 grit oil stone, stoned all of the light surface rust off of those surfaces, and that revealed a really nice hand scrape finish everywhere on the machine, including up on the tower, just above the column where the ram rides. And I've stoned the bed as well. The bed is in very good shape. There's no holes or anything drilled in it because it shows signs of never having a vertical milling attachment, which I definitely want to get for this in the coming years. I feel like that would make the machine even more useful. But the table is really clean. There's no big dents or chunks missing out of it. There are, however, some small little ding marks, probably from dropping parts or something over the years. But over the years, I'm sure that'll wear in nicely. The table seems to be as smooth as I can get it with the stone. I haven't taken off too much just to make sure, just to get rid of the rust and not affect the accuracy of the machine. This is a universal horizontal machine, so the entire table and saddle pivot at the center point. So this can turn 45 degrees in each direction. I'll demonstrate that in a little while. But as far as a new machine, this thing, I don't think I could beat it for what I paid for it. Luckily, the fellow I bought it from was fairly knowledgeable about the machine, and he remembered it running when he was in high school, and that doesn't seem to be more than 10 or 12 years ago. So hopefully this will be a good machine for me over the next 20, 30 years, as long as I have it. Hopefully I'll have it the rest of my life. But let's go ahead and show you some of the features of the machine. Okay guys, so here is the side of the machine. Here we have all of the speed adjusters for the machine. This has spindle speeds geared between 28 and 1100 RPMs with 2 ranges, as well as 2 motor ranges. So the motor can run at various currents, and it'll run at half of its speed and then its full speed. So we have various RPM difference that we can get over 1000 RPMs of speed adjustment. That seems fairly slow for a machine this size, but when you can run cutters that are close to 10 inches in diameter, you really need those low end speeds. And I don't really plan on running any carbide tooling in this machine because I don't have any for it right now. And no high-speed steel cutters for this should require more than 1100 RPMs that I need for this. So this machine is wired currently at 220 3-phase, and we have the bus bar drop directly above this machine, so it's wired up and active. I have a built-in fuse panel to the machine where I can disengage and engage power input, and I can also do lockout for it when I'm doing maintenance on it. The entire base of this machine is an oil housing, and where this lid is right here, we can put cutting oil into the base, and that actually will go to the oil pump in the bottom corner of the machine, and that will pump oil up through a fitting on this side of the machine. And with the correct hoses and fittings, we can run cutting oil and full-on flood oil onto the cutters for cutting aluminum or steel, so we can keep the part cool and the cutter lubricated. Otherwise, on this side of the machine, there's a forward and reverse switch for the motor. We can run the spindle at just about any, for left and right-handed cutters, and we have the various speed adjusters on there. You'll notice on this side of the machine, the hand wheel is only on one side, whereas on most Bridgeports they have a setup for a hand wheel on both. That is because it's a universal mill and it has 3-axis power feeds, and oftentimes you'll only be using one hand wheel. That and this end of the hand wheel, when you remove the hand wheel, there's a shaft with a keyway in it where you can run a banjo for gears to a dividing head to do helical turning and all sorts of direct indexing off of this, which really makes this machine super versatile, and I look forward to doing that. So right next to the machine, I have a small rack where I have some cutters and various holders. I have a homemade fly cutter I made several months ago. It should work well with this machine, haven't tested it out yet. A nice ER collet chuck. This is ER-25. And this is from one of the Haas machines, so we can use collets down to roughly 1/16 of an inch and up to 3/4. That gives me a decent capacity. Got a nice 4.5-inch Niagara high-speed steel vase mill. I took this out of the wax actually this morning, so this is a brand new cutter. It's in really nice shape. I can't wait to see what this thing can do. And then over here we have a stub arbor Albridge style 1/2-inch drill chuck, so I can use this for drilling as well as milling, and I definitely want to see how this performs for drilling with some of the larger drill bits. I'd like to look to get a 40 taper to Morse taper 3 adapter, so I can use some of the Morse taper 3 bits I have, so I can take some bigger drill bits out there. But this is a Criterion 3-inch boring head, and that can fit directly up in this spindle. Haven't used it yet, but you'll see what we can do with this and try and turn this into a horizontal boring mill for a little bit. That'll be fun. And then on the far right of this rack, I have the 3 arbors that I use primarily. One's 1.25 inches, one's inch, and there's another one that's 7/8, because most of my cutters are that size. I will be looking for an 1.5" arbor because I do have some cutters that came with this that are 1.5", but most of those cutters are for very large gear pitches that I don't intend on using anytime soon because I don't have any gears of that size to make. But over here, we have the overarm support, and this fits up onto the ram via dovetail and a locking collar. This has a split bushing, so you can adjust the bushing to be a certain diameter. Right now that's fairly worn out, and I probably will look into replacing that with a piece of phosphor bronze over the next couple weeks. Then also we have the drawbar for this machine. It's 5/8 11 standard for 40 taper. Okay guys, so this is the other side of the machine. We have our feed rate direction knob right here, where we can change the direction of the feed, and you only really have to do that when you change the rotation of the motor, because all of the controls can be done via the levers in the front of the machine. This has our start-off switch for the motor over here. We have a reset panel next to that, and for safety purposes and for OSHA standards, we keep our safety shears here in case of any incidents. So right now, the machine is set with no power running into it. I will show you it in operation in probably the next scene. So from there, we have our feed adjustment knobs. Now these two knobs have one has 3 different ranges and the other has 2, and there's a small feeds chart on the bottom of the knee that tells me the feeds in inches per minute, and that range goes from roughly 1/2 inch a minute, which is really slow, all the way up to 6 inches a minute. And I believe that's in inches per minute. I haven't looked into that range just yet, but once I get more familiar with the machine, I will confirm that. So then up top, we have our ram, and that is locked down by 2 1/16" locking nuts, and those hold the ram in place, and we can slide the ram out and forward so we can run an overarm support for this machine. I have a Kurt 6" by 9" vise set up on here, beautiful vise with a swivel base, and we'll show you taking some cuts with this. This came off of one of the CNC bed mills next door in our other shop, and I can't wait to see what that vise can hold so we can put some big parts in here and take some big cuts with some plane millers. The adjustments for the pivoting from this machine, there's 2 locking nuts on the sides with 2 alignment pins where you can swivel the table. I'll show doing that when I go through more of the operations of the machine. So as of right now, I'll show you moving the ram outward. Let me go grab the wrench for that real quick. And from here we can take these 2 nuts, loosen them, and then from there we can come to the back of the ram, and this does not have any rack and pinion driving mechanism to move the ram forward. This is entirely just gravity and sitting on the dovetail ways. So I'll go ahead and slide this forward. Once you get it moving, it becomes a little easier to move, but once it's been locked in its position for a while, it can be hard to move. So we'll go ahead and lock those down, and I like to make those fairly tight, just so I don't have any movement in the machine when we're cutting. Okay, so now with the overarm support out, with the ram out rather, we can put the overarm support on there and a cutter arbor that we can use to hold tooling. From there, I guess I'll show you this machine running with the power feeds, and then we'll set up a cutter, take a cut, and see how this machine handles it. So go ahead and turn the machine on again. Show you rapid traverse in 2 axes. Right now, the axis goes seems at 20 gauge all the way, so we will show you those gauge. Right now we're going in a lower RPM. Now we're going to engage the rapid cable and move it X and Y simultaneously. That's pretty cool. We'll do that again in reverse. fairly quiet right now. I'm just waiting for the motor to kind of break in, and the oil to break in rather, and everywhere where there is an oil reservoir. This machine hasn't probably seen fresh oil in over a decade. So right now we'll go ahead and show you putting an arbor on with a tool, and from there we could probably take a cut. So we're going to go ahead and install an arbor on here now, and I'm going to choose an 1.25" arbor to put on here, and we're going to run a 4-inch wide, 3.5-inch diameter plain milling pipe. Go ahead and insert the drawbar. Then we'll go ahead and take the arbor we're using. What I'm going to do is I'm going to wipe that arbor clean of any oils, grime, or chips, and then I will do the same with the spindle. So I'm just using a paper towel for this. I do not have a rag right now, just to take everything out of the spindle. Now, aligning the drive dog keys, we will insert the arbor into the spindle nose, and then from there we can go into the back of the machine, threading the drawbar so it's tight, and we'll go ahead and make sure that's tight. Grab the 15/16 locking wrench for this, and go ahead and tighten that arbor in position with the machine in a low gear. Now that arbor is tight, we'll go ahead and wipe any chips or oil off of this arbor. Go ahead and take our key, our cutter, and some of our spacers for this, and we will install them onto the machine. So using a decent orientation, what we'll do is we'll take our piece of key stock. This takes 5/16 key. We'll install that, and we'll take a spacer to move the cutter away far enough from the spindle nose, and we will install the cutter, the keyway lined up, so this will cut in a right-hand fashion. So from there, we'll then go and install another spacer, line that up with the key, then our drive bushing. Now this drive bushing will ride inside the overarm support, and that'll provide the extra out-bearing support for the cutter and arbor, because these cutters do weigh quite a bit when they're this size. So that is, once again, 3.5 inches in OD and 4 inches wide. So now what we'll do, we'll grab the overarm support, and we can now install this on the dovetail. But first, what I'd like to do is to take this, clean these dovetail surfaces of any chips. Then we'll go ahead and grab an oil can with some whey oil, and what that'll do is that'll provide us with a little bit of lubrication to get this to go on fairly smooth. So we'll lube this area here, dovetail there, and we'll go put a liberal amount of oil on the drive. So now with all the bushings installed, with all those spacers installed rather, you can go and take the overarm support, slide this onto the bushing. I like to get that lined up fairly flush. Not that went too far. Our spacers in line, the bushing riding. Now we're going to go ahead and take our locking nut, and then grab a wrench for that, and tighten this arbor down so we can commence and cut. Okay, tight. We got that oiled. This is also our knee handle for this machine. Now we're going to go ahead and tighten down our arbor support, which is a 1-inch wrench for that. Go ahead and tighten that down in position. Now, this machine is set up to do some cutting. So from there, we can turn the machine on. Right now that's going at a slowest RPM, 28 RPM. set up one of these arbors on this style machine on a horizontal mill. And what I like to do is, if I can keep the cutter as close to the spindle nose as possible while giving enough clearance for the vise, that's better just so we're using the support to our, we're lowering the leverage of the cutter by keeping the support close to the spindle. So I'll go ahead and turn off the motor now. Now we'll take a piece of stock and take a cut. Okay, so now we're going to set up and go and take a cut. So I'm going to grab my parallels. These are 1-inch parallels, or 1/16 parallels, I believe. Take our part, press it in between the jaws and the vise. I like to keep my parts fairly centered. You go ahead and tighten down the vise. And to make sure we're seated on the parallels, take a mallet and just like to give, let's get this out of the way. A couple taps to make sure our part's seated. Okay, our parallels still can move a little. Now they're nice and tight. Okay, now with the part tight, you go ahead and turn the machine on and come on and touch off on this machine on this part. Now this is 6061 aluminum. I'm running at 365 RPM. Cutter's 3.5 inches in diameter. I calculated that from a basic cutting formula of 4 times the material surface feet per minute divided by the diameter. And having a 3.5 diameter, 4 times 300 surface feet, which is fine for 6061 aluminum. I came up with 400 RPM. The closest on this machine is 365. So I'll get ahead and turn on the motor for the machine. Then you're going to engage the spindle. Now, the spindle engaged, go ahead and feed the cable closer to the cutter. Fairly centered cutting. I can't wait to actually take some big chips with this with a sharp cutter, like that face mill I demonstrated before. But I'm going to go ahead and turn the machine off, pull it apart, and clean up. Hope you guys enjoy this. If you want to go ahead and hit the like button and the subscribe button below, that would really help me out. Try to build up my channel a little bit. I'm new to YouTube, and I love the YouTube community of all the other machinists out there. I want to give a thanks to Keith Rucker, Adam Booth, Keith Fenner, all those machinists out there that have influenced the younger generation. I speak for myself from that. I love machining now because of YouTube. I've been buying machines and using them, and I thank you for getting me into that field, and now I can make parts for all of the stuff I work on. So thanks again. Hit the like and subscribe button if you like, and I'll catch you in an upcoming video a little bit more about me.